So today we are going to be looking at the qualitative analysis for the forthcoming exam, that's chemistry practical. We have some of the tests here. Let me just read out my own the question I have. I have a question here. Said that the question said C is a mixture. It's a mixture of inorganic and organic compounds. Carry out the following tests. Record the observation and inference. Record the observation and inference. Test for any gas evolved on the table below. So look at the table. This is a table which I have drawn here, although I'm going to be making more tables when we're done with this ones, the test we have here. So will be, as I'm doing the experiment, I'll be giving you all you need to know. In the exam, so we're going to be analyzing lead carbonate and then starch from the information received. A mixture of lead carbonate, lead triazole carbonate 4, and starch. So we're going to be analyzing it now. I want you guys to watch, to pay attention and watch very well, because I'll have two methods of identifying lead, which is somehow, one of them is somehow hidden in this. It is not very obvious in this in the information paper. But then one of them, we have two tests. One, and the second one will really blow your mind. That's why I want to encourage you to pay attention, work very well. Even if you miss copying down some things, you can still do it. All right, let's go ahead and do the justice to what we have here. So what I have here is the salt in question. Then the first question says C plus dilute nitric acid. Filter, divide the filtrates into 4 portions and keep the residue. So that is what we are going to do. Let me get this one ready first, the filter paper. Let me get this one ready first, because I did not remember to fix it up to save time. This is how it's supposed to be. Then I put okay. Instead that add the dilute silver nitrate. Dilute silver nitrate, I think. Okay. Remove everything. Observe this and going on here. This gas will go away. So these guys are just kept. I don't know how I'm going to do this thing now. Let me add more this thing. The thing just it was too fast. Okay. Okay, I think it's done. Yeah. Now the gas that just came out, I tested because we have lime water there, so that we should, in the information, lime water should be provided. Now I've tested this. It turns lime water milky. This is what we have. The gas has turned lime water milky. Look at it very well. It's a very good there. How do I make it obvious? I need a black background. change the black background to make it better. Alright. Now you can see that, I believe you can see this now. From this background, you can see that the lime water is there, or it has already been turned milky somehow. This is as a result of the gas that just came out. So what I did not do is to test with litmus paper, because we are given litmus paper. That means, let me see if I can get more of this. We test with litmus paper. I don't know, I forgot to tell. Okay, see coming out. Damp litmus paper. Okay. The thing is that I think it's because it's a weak acid. The color is faint. I don't know if you can see it there. This is the blue, this is the red. There's a little faint color here. And this is enough to let us know that this is what, an acidic gas. So let's just save some time. Yes. It's a there's a slight reddish color at the tip of this. I think that should be because this gas is actually a weak acid. So what we have here, and also you can see that we have some white precipitate inside. The whole thing did not dissolve. That is to say, we have the mixture is that's right. So from what we have observed, we notice that a gas colorless, odorless gas turns blue, litmus paper red, and also turns lime water milky. So what we have here, the gas is what? Carbon 4, and then the gas is also acidic gas, and then the turning red, blue litmus paper red means that it's acidic gas, and the last one is what else do we have here? We have partially or partly soluble, which means the compound C is a mixture of soluble and an insoluble compound. This one is done. So this is what you expect, what you are expected to get in that. The next one says filter and divide into 2 portions. Actually, we're not going to wait for this. I've already done the total filtration of what you are supposed to get. So we might not, now you add so that you can filter in order to save time. So you can see that the filtrate is colorless as it's coming out. So I have already, this one did not come out completely. Okay, we still have some there. So we will go ahead with the filtrates I have already made before doing this video, so that we can save time. If I'm to wait for this, it will take a lot our time so much. So now this is the one we're going to work with. we said that divide into 4 portions. We're going to be dividing into 4 portions. This is the portion number 1. Two, three, and finally we have our 4, the 4th portion. So now the first portion add sodium, dilute sodium hydroxide in drop and then in excess. So let's see what we can do. What we add in drop, what will happen. And add in drop. We have what? White precipitate. We have what's precipitate here now. As you can see, the white precipitate is there. I just use my color to see very well, to serve as black background. I didn't even remember that my color can get this thing done. so now the next thing we're going to do in excess, add in excess. So in most cases, if you want to get the best results, you reduce the volume of your mixture, so that can easily identify what happens. Now I reduce the volume so that I will be able to know exactly when it's going in excess. Now it's soluble. It's soluble in excess. What do we do here? We come here and say what? As you can see, it's soluble. Everything, clear solution. We have what? This one gives us white precipitate, soluble in excess. So what we have here is lead 2 ion, calcium ion, likely present. Now the next one, so the second portion adds aqueous ammonia. So we add, we have a precipitate, white precipitate too, with aqueous ammonia. Then in excess, let's try the excess one. Then in excess, we add in excess now. It's still what? Insoluble. It's still insoluble. Okay, so that this thing has finally changed very well. I think that's it. That's the litmus paper, blue litmus paper has finally, that tip has finally changed. Has changed very well. You see it is now a part of this place is reddish, and some other part here is reddish. I think the thing has reoccurred because it's a weak acid. The thing will take a kind of slow, it will be slow in action. So now look at it. What we have here is what? Insoluble. Insoluble. For the fact it's insoluble, it has already deleted the presence of what this what we have here, white precipitate, insoluble in excess. So what we have here, calcium ion absent. Let two ion likely present. So now the next one we're going to do now, you say that, I think I will on this thing, you say that to the third portion add dilute hydrochloric acid, and then heat gently. So now let this thing be warming up there while we carry out our test. So add dilute hydrochloric acid. I'm adding it now. Usually this is hydrochloric acid. Don't know the one I'm using. Let me see. What else? Okay. The thing is, this is a precipitate. That's a precipitate form. Now we have white precipitate. This is it took some time. I'm even wondering whether actually this is the real acid. That's the precipitate is coming out. You can see from the black background, you can see it very well. I was wondering because it did not show any visible reaction initially. So we have what? White precipitate. Then it said we should heat. So let's see what we do when you heat it. What will happen? So that heat, then allow to cool. Heat and allow to cool is how to make it cool faster. Maybe another thing now. So this thing is coming out. You're seeing it. Let's see. I believe you can see what's going on there. It's dissolving. It dissolves. Now, this one can now go off. You can see that the whole thing has dissolved. I want to use my body as a background to show you very well. Now we have it said it should allow it to cool. Let me see if I will put it in something that's cool. Well, I'll come back to this before the end of the video. Let me put it in a place where it will cool. Now the next one said the fourth portion, this is the fourth portion, it said that we should add what? Iodine solution. That is the mind-blowing test for lead nitrate. Then after that, I will tell you why it's so. So this is one thing that is hidden in that place in the information paper that seems to be, and we already know that. Let's see if facts. See, what we have is yellow precipitate. Now, this yellow precipitate is yellow precipitate of lead iodide. Why is it so? It's because in iodine is not soluble in water. So to get iodine solution, you need to dissolve iodine in potassium iodide solution. So making it possible for you to use it. This is my own prediction, but I don't think you can go beyond that. I don't think there's any other way of identifying it. Besides the identification with this, identification with the dilute hydrochloric acid, we can also do that with what? Potassium iodide. Potassium iodide can be done. The potassium iodide in this exam is hidden in the word iodine. So I don't want you to rule out the idea of using iodine to test for this, perhaps, because all I'm showing you here is all the text for this very compound. I think we have this thing now. Yeah, this thing is back. It's cold now. You can see the precipitate coming out again. The precipitate is back. So let's complete this side and go ahead with what we have. Soluble when hot and insoluble when cold. What do we have here? Lead 2 ion present. So this is the fourth one we have this, and this is one of the confirmatory tests for what? Lead iodide. You give the lead chloride. Yes, lead 2 chloride. What am I saying? Lead ions. For test for what? Lead ion. This is one of the ways of testing for it. So it gives a yellow precipitate of lead iodide. So what we have here is yellow precipitate formed from confirming what? Lead 2 ion confirmed. So these are the possible way of identifying the lead. It's either they use chloride or they use iodine. So don't just, why I'm doing so that you don't just rule out this, because we know that it's only used for what? Test for starch. Or always have in mind that the potassium iodide, you can use potassium iodide or you can use potassium dichromate. Two of them can give you yellow precipitate. So don't just rule it out. Don't just rule out iodine in this test for what? Lead. Alright, let's continue with the last ones, the other ones we have here. So let's see what we have in the iodine solution. Our residue is this. This is the residue that we have. We'll add iodine solution to it. You can see we have a blue-black solution, blue-black color coming on there, as you can see. Or should I put it in a test tube? Let me add in the test tube. You can see the color, the blue-black color that's coming out there. That's as a result of, that's evidence of what? Starch. The starch is present in this. So this is where we'll call it a day. So we have what? Blue, blue-black color, confirming what? Starch. Confirmed. So this is where we'll end the test. Thank you so much for being part of the class, and if there's any question, you can leave in the comment section. And if you are joining us for the first time, do well to subscribe. Please don't just keep the question with you. Drop it there, we can always attend to you. And share and share this video so that it gets to so many people. Thank you so much.